Oh, my sound was turned off. Hello, good day. We are in geometry covering CO29 using properties of medians. We've already talked about things like perpendicular bisectors and angle bisectors. This is kind of the third of those special segments that we can draw within triangles. And if you recall, both perpendicular bisectors and angle bisectors are kind of the middle of a triangle, right? Where the three perpendicular bisectors intersect, called the circumcenter. How is that the quote-unquote middle of a triangle? What is the circumcenter equidistant from? The perpendicular bisectors come from the sides. They're equidistant to the three angles. Okay? Angle bisectors, their point of concurrency is called the incenter. And what's the incenter equidistant from? How is that the middle? The sides, okay? So today we're going to kind of talk about a third middle called the centroid that is found with the point of concurrency of the three medians. And a median is a segment in a triangle going from an angle to the midpoints of the opposite side. Okay? It is a segment in a triangle going from an angle to the midpoint of the opposite side. So what do you think medians get most confused with? Median. No. Emily? Midpoint? No. Angle bisectors, right? Because both of them come from an angle and go to the opposite side. The difference is an angle bisector bisects the angle and just goes to the opposite side wherever it happens to land. The median just comes from the angle and it goes to the midpoint of the opposite side. So we're going to draw both of them out here kind of in this section just to differentiate the two. Okay, what an angle bisector does, let me see if I can draw, let me make my triangle. It's kind of like that, okay? An angle bisector comes from an angle so that it bisects that angle, and obviously you can see it does not intersect the opposite side at the midpoint, right? It just hits it wherever it happens to land, okay? What a median does, so this is what we care more about today. I'm going to try and draw a similar-ish triangle here. This is kind of, it's pretty good, okay? What a median does is it must intersect that opposite side at the midpoint. So I'm going to draw that in first. It makes it kind of easier to connect them. And we're just eyeballing this. It looks to be about the middle of that side. But the median would come from this angle and go to that midpoint. You can see it doesn't bisect the angle, right? So the difference between the angle bisector and the median, they both have to do with kind of a middle, but the angle bisector, it bisects the angle, hits that opposite side wherever. The median does not bisect the angle, and it goes to the midpoint of that third side. Okay, you see the difference? Yeah? Yeah, okay. So let's draw in the other two medians here. So I'm going to put the midpoint of this one right about there, I suppose, and draw a median to connect that. And the third one, right about there, midpoint, and bring that to the angle. And we're freehanding this, so it might not be perfect, but your three medians should intersect in the triangle at a point called the centroid. I want to be the person that names these points. You have the circumcenter, the incenter, and the centroid. I like it, okay? So the centroid is the point of concurrency of three medians. And there are two things that we care about when we're talking about a centroid. Okay. First of all, it's what you can call the gravitational middle, or the gravitational center. Okay. In that centroid point is where if you were to balance a cardboard triangle, balance a triangle on the tip of a pencil, that's where you would need it to be. So you'd place the triangle on its centroid on top of the pencil, and it's going to balance there. So of any of these three centers that we talked about, circumcenter, incenter, and now the centroid, this is probably the truest center as far as the balance is concerned. Okay? So the gravitational center, and what we mean by that is that's where the triangle balances. The other thing the centroid does, it divides the median. Well, I'm not going to fit that. Divides the median in a 2-to-1 ratio. Divides the median in a 2-to-1 ratio. What does that mean, 2-to-1 ratio? There's two somethings for every one something, right? Or basically one piece of it is twice the other piece. So if I told you that this length of that median, that short section of that median is 5, what would the long section of that median be? 10. And the total length of the median would be 15. Okay? So 15 length divided into 2-to-1 ratio would be 10-to-5. One's double the length of the other. Right? If this one is 6, what would the short section of that median be? 3. It would be 3. Right? And if this is 8, what would the short section of that median be?
Well, how did you know to make it a 3 and not a 4?
That was going to be my next question. Good. Just hang on to that there. What would the short section of that median be? 4. Okay. So the next logical thing is, how do you know which is the short section and which is the long section? Okay.
The long section comes from the corner.
Right. The long section comes from the angle. The short section will go to the side. Okay. So the long sections of these, I'll outline them in blue, are the ones that come from the angles. Okay. So far, so good? Okay. All right. So now down to some applications, some practice here. In the figure, P is the centroid of triangle XYZ, and we're told that YP is 12. So let's go ahead and label YP to be 12 here. LX is 15, and LZ is 18. I don't want to put 18 in there because that's, LZ is the whole median. If I put 18 here, you can kind of tell it refers to LZ, but maybe it's YN. So instead of writing that one in there, I'm just going to box this so I remember to refer to that if I need to. So what's the length of LY? What's the length of LY? Elise? 30. So for LY to be 30, you're dividing that into a 2-to-1 ratio there. That's the side of the triangle. It's not a median. But knowing that point P is a centroid, and remembering our definition of a median, it comes from the angle and goes to the midpoint of that opposite side. What do we know about point L? It's the midpoint of side XY, right? Which means that LY is going to be 15. Yep. Okay, so LY 15, mark that in there. YN, what is YN going to be? Daniel? 18. How'd you get that?
Well, when YP is 12.
Yeah.
That means it has to be 6.
Right, so YN is the entire median. Okay, knowing that that long section YP is 12, it means that short section PN is 6, applying that 2-to-1 ratio. So the total length of the segment YN is 18. Good. LP. What's LP? And here's where we want to bring back in that LZ is 18. What's LP? 6, right? If LZ, the whole thing, is 18, that has to be divided in a 2-to-1 ratio. The only way to get 2 parts to 1 with 18 is 12 to 6. The short side is LP because it comes from the side, and we get 6 there. Sebastian, was that a hand or a stretch? Very good. Finally, XY. What is XY? XY is 30. We already have both of those pieces found, so there we go. Okay. According to my calculations, triangle YPM is congruent to triangle ZPM. So let's outline triangle YPM and ZPM. Okay. We know that this is 12. Yeah. Dost thou agree and explain why or why not?
Yes, but I don't know how to
Gabby.
Yes, because first of all, P and Z are equivalent. PZ is equivalent to PY.
Okay, so knowing that LZ is 18, right, and we got LP to be 6, that means that PZ is 12, and so we have congruent sides here and here. Give me another piece of this puzzle. Alan?
MP and NPR share the same side.
I love the reflexive property. Whenever there's a shared side, right, just mark that congruent. Lucas?
YM and MZ are equal.
Because?
Because M is right in the middle of line Z.
And we know that because we know it's a median, because we were told that point P is the centroid. And so what triangle congruency theorem allows us to conclude that the two triangles are congruent? Side, side, side. Okay? We didn't really explain that in words. If you had markings in there, that's good enough for me. Questions on medians? Okay. We are going to go on to CO30, and I'm going to pause the video because I got to go run and get some rulers for you. So we will be, oops, I don't want to do that. We will be right back. All right, and we are back. So in CO30, what I'd like you to do, I got to put the marker back in the holder here. Hold on. What I'd like you to do, it says create 4 triangles using the following side lengths. The first one, 3, 5, and 7. The second one, 2, 2, and 5. The third one, 3, 3, and 4. And the fourth one, 3, 4, and 8. Make sure you're using centimeters, otherwise inches gets to be really big for the page. So in centimeters. Sorry that this artwork is on your page for you. I thought that putting it here would be for my use. I didn't realize it would print out that way. So my apologies for that. But take a few minutes and make triangles as accurately as you can with those given side measurements.
Yeah.
Well, I'm ready to divulge them. So, okay. So you've had some time to see if you can figure out how to draw triangles with the given side lengths. Were you able to draw a triangle with side lengths of 3, 5, and 6? Yes.
No.
Oh, we'll try again because you are able to. How about 2, 2, and 5?
No.
No. 3, 3, and 4?
Yes.
And 3, 4, and 8? No. Okay. If you are able to draw a triangle with side lengths of 3, 4, and 8, your measurements are off or you have discovered a new, different dimension. So why are some triangles possible? Or maybe the better question, why are some triangles impossible? You know, what about drawing a triangle with side lengths of 2, 2, and 5 don't work? Mackenzie?
I think it's because the two smaller sides have to add up to be the bigger side or more.
You are about 95% correct. Yes. Those two smaller sides, their sum has to be greater than, not equal to, but greater than that third side. And here's the reason why. Let's look at that 2, 2, and 5. If I draw a segment with a length of 5 here, is green, I'm going to use red. Red shows up a little bit better. So from 2 to 7 is a length of 5. Even if I make my triangle as flat as possible, I mean, how am I supposed to make it so that a length of 2 and a length of 2 are going to connect to make a point? Because even if you lay them flat, they don't even reach each other. You know, and as you lift them up, they're going to get further and further apart. Okay? Same thing with the 3, 4, and 8. If I have a segment that is 8 centimeters, to go from, why is this blue? 1 to 9 there. Okay? If I have a segment or side length of 3 and a side length of 4, even laying flat, they don't meet, right? Whereas with 3, 5, and 7, one that you were all able to do, let's draw a 7 centimeter segment here from 2 to 9. If I've got one side that's 3, so from 2 to 5, and one side that is 5, from 9 to 4, notice they overlap, right? Right here. Okay? And because they overlap, as we lift them up, this one's going to come up like this, right? This one's going to come up like this. Where they intersect, that's where my triangle is going to be, roughly. Does that make sense? Okay? Why some work and why some don't. The 3, 3, and 4 work as well because that 4 centimeter long side, those 2 of 3 will overlap. And as Mackenzie said, you know, rather than drawing these segment lengths out and seeing if they overlap or not, the basic rule of thumb is the 2 shorter sides have to add to be greater than the third. Okay? And that is where we get, on the second page here, the triangle inequality theorem. The triangle inequality theorem states that in a triangle with sides A, B, and C, A plus B must be greater than C. Okay? In a triangle, or for a triangle, with sides A, B, and C, A plus B must be greater than C. Right? Of course, it must be true the other way also. You know, if you add sides A and C together, it's got to be greater than B. If you add sides B and C together, they have to be greater than A. But as long as you make side C your longest side, if this works, then those other two automatically work also. You know, because if C is your longest side, if you're using your longest side and adding something to it, obviously it's going to be greater than the other shorter side, right? So you really only need this one and make C your longest side. If the shorter two sides sum to be greater than that third side, you've got yourself a triangle. If not, or if they're equal, then you don't have yourself a triangle. Okay? Why can't they be equal? Why couldn't side lengths be like 3, 4, and 7?
I did one for 3, 6, and 9.
I'll come take a look at it. Why can't that work? Yeah. Right. The only way to make them touch is if you lay them flat, and that's not a triangle. If all 3 sides are laying flat, you don't have any arc there. You don't have any degree measure. Okay? Questions, comments, concerns, complaints, comments, congratulations, or criticisms on this? Okay. This is where we ended on Monday. We had a little bit more time passing things out because there were more people here and just other interruptions and things like that. So this is as far as we'll go today. You've got a quiz posted in Google Classroom on 29 and 30 up to this point. Tomorrow, I will post a recorded lesson. It'll wrap up PO30 and be kind of a review summary of perpendicular bisectors, angle bisectors, and centroids. So you'll watch that video on your own time outside of school, and then complete the Google quiz associated with it also outside of school. And then next week, we're back to one live lesson and one recorded lesson.
Is this one graded?
This is going to be retaken until you get 100% on it, like most of the other quizzes that you've had. Okay. All right. That is How You Math.